We've talked about this way back in the beginning of the semester. We're going to say under appropriate conditions of pressure and temperature, matter exists in three different forms. Matter can exist as a gas, a liquid, or a solid. Now, when it comes to each of these different states or phases of matter, they have different properties that are specific to them. So if we take a look here, we're going to have a microscopic explanation for the behaviors of all three phases. Now we're going to say gases, they assume the shape and volume of their container. So if you have a large container and you input gas in there, the gases will spread out as far as possible to take up as much space as they can inside the container. We say that this is the gas behaving ideally. We're going to say liquids. Liquids assume the shape of the portion of its container it occupies, but not the volume. Not always. Because let's say we have a container that can hold a gallon of water, and the gallon is shaped a specific way. But let's say we don't have a gallon of water. Let's say we have only half a gallon of water, and we pour it into the container. The water will take up half of the volume and take up the shape, but it won't be able to take up the rest of the volume because there's not enough water. So water, liquids, always take up the shape, but not necessarily the volume. If there's not enough liquid, it won't be able to fill up the entire container. Solids are very stubborn. Solids maintain a fixed volume and shape. So you have a container, you dump a rock in there. The rock does not conform. It doesn't change its shape to fit the container. It doesn't try to fill up the container. It is what it is. Now, compressibility. We've talked about this as well. Compressibility has to do with us being able to push down on the molecules that make up that phase. Now, gases are highly spread out inside a container. But if I apply pressure, I can compress them, squeeze down, so that those gas particles, gas molecules, get closer and closer together. So we're going to say gases are highly compressible. I can increase the pressure and squeeze their molecules closer. Now liquids are not far apart. They're right on top of each other, but they're fluid. They can move around each other. There's not much space, not much free space between them. They're rubbing up against each other. So we're going to say that liquids are not really compressible. We might be able to squeeze a little bit, but overall they're not compressible because the molecules are already as close as they're going to be. They're just rubbing up against each other as they're sliding around, moving around. Solids, their molecules are frozen in place. They're already as close as they're going to be. Okay, they're stacked on top of each other. So we're going to say that solids are not compressible, period. Not at all. And then we're going to say viscosity. Viscosity is just the resistance to flow. Resistance to flow. That means it doesn't want to move. So we talked about this earlier too. If you make a comparison between a bucket of water and a bucket of honey. So if you take the bucket of water and turn it upside down on someone's head, the water is going to come right down and drench that person. But let's say we have a bucket of honey. Honey moves a lot slower than water. Honey is more viscous. It doesn't want to move as fast. So if I take that bucket and dump it over someone's head, some of it might come out immediately, but a good majority of it's going to take time to come out. How do we decrease viscosity? If you increase the temperature, you're going to excite the molecules. The molecules get faster, that honey will come flowing out faster. Okay, so if you increase temperature, you decrease viscosity. So we're going to say gases are bouncing all over the place. They move incredibly fast. So they're going to have low viscosity. They don't have a resistance to flow. They want to move as fast as they can. Liquids have moderate viscosity. Depending on the liquid, they can flow fast or slow. And then solids solids really don't flow. They're just what they are. So solids have a high viscosity. So these are each of the microscopic explanations of each of these phases of matter. And remember, especially the terms viscosity, because these are the terms that you're going to be associating with intermolecular forces and all the other things that we talk about when drawing a compound.